want to start off here by defining what Git is. Git is what we call a version control system that is free and open source, and it's the most widely used version control system in development today. Most programmers interact with Git on a daily basis. So what is version control? Version control is basically a way that we as programmers track our code changes. We basically save an initial version of our code into Git, and then when we update code, we can save it into Git again, and again, and again, and again. And throughout time, as our code continues to change, we can look back at all of the changes we have made over time. This helps us to see and understand what we did when, as well as track down bugs or go back to a previous version of the code if we need to. So let's look at some of the terms that you're going to see in this video. First of all, I use the term directory, which is also known as a folder on your computer. When I reference the terminal or command line, I basically mean an application that runs on your computer, which is just an interface where you can type in text commands. You can navigate around files and folders, create files, change, update things, install and run programs, and much more. You might also hear me use the term CLI, which is just the command line interface. Many programs that you install as a programmer will require you to interact with them via text commands in the command line. So you will be typing out some text and hitting enter instead of, say, double-clicking on a folder icon on your desktop. Just think of it as another way to run a program. Now you might be wondering, why are we going to use the terminal or command line instead of using one of these beautiful applications that handle interacting with Git for us? Well, as programmers, it's always good to use the terminal so you learn the Git commands and workflow of Git, as well as become accustomed to it as a developer. You are going to be using the terminal a lot to install CLIs, run programs, search for things, etc. throughout your development career, and learning Git is a great way to get started with the command line. CD stands for change directory. It's basically the same thing as when you double-click on a folder using the icons on your desktop. Well, in the command line, if you want to move into a folder or even up to a parent folder, you'll use CD followed by the directions to get to whatever folder on your system you want to get to. A code editor, of course, is a place to write code. You'll probably see this in a lot of different programming videos, but just in case you are unfamiliar with it, you can write code anywhere in a text document, word processor, anything. But there are special ones that are designed with lots of tools and features for programmers, and these are called code editors. Now, some people get confused by the word repository because it has multiple meanings, but in the world of programming, it usually refers to a Git repository, which is basically just your project or the folder place where your project is kept. You can call it a repository. People also sometimes confuse Git and GitHub. Now, Git is the tool that tracks the changes in your code over time. GitHub is a website where you host all of your Git repositories. Being online, it makes it easy to work in groups with other people and organize your projects into a portfolio for you to show potential employers. So here are some of the Git commands we're going to cover in this video, which you will be typing into your terminal or command line on your computer. They are clone. For example, if there's a repository that is not on your local machine, but it's on GitHub and you want to bring it down on your local machine so you can use it locally, you use the clone command. By the way, all of these commands are lowercase, not uppercase, as we're going to see as we go through the examples in this video. When you have updated files or created or deleted files and folders, you're going to want to tell Git that you made changes and that you would like Git to track those changes. So you use the add command for that. As I said earlier, Git is there for you to save the changes you make in your code. So you do that through a commit, and we call it committing your changes. Once you have made changes locally on your computer and you are ready to put them in Git, you tell Git to track them through the add command, you save your files to Git through the commit command, and then you upload your files to a place like GitHub or another what we call remote repository or GitHub alternative like Bitbucket, GitLab, and there's many of them. You do this through the push command. When there are changes to your code on GitHub and you want to bring those to your local machine, then you use the pull command. You pull down changes from the remote repository. Those are all the commands that I want to cover to get started. Again, we're going to go over examples of each of these. The first thing you will need to do is, of course, sign up for an account on GitHub. This is pretty straightforward. You enter minimal information and then you sign up for an account. You will get an email that will ask you to verify, and then you can log into your account. When you log in, you will either be on this page, which is your profile page that you can access from this drop-down menu, or you might be on the dashboard page here. Either way, you will have access to this green button here, or this plus sign and the drop-down here, where you can create a new repository. Now, a repository is basically a project. It's all of your coding, files, and folders for whatever kind of application that you are building. For example, this is a repository that I have. It's for a curriculum app that I've been building. You can see the mockups. Pretty straightforward application. And in this repository, this is my complete project with the folders, and all of my coding files are inside of these folders for this one application. Each application or project is in a separate repository. So I'm going to go ahead and create a new repository here. Give it a name, demo repo. By the way, repo is just short for repository. I'm going to leave these settings as they are and click Create Repository. Now you can create your files and folders for this repository locally on your machine, or you can create them straight in the online editor on the GitHub website. So I'm going to go ahead and create a basic markdown file called a README. And this is the most basic file that you will find in almost every project that contains text to describe what the project is about, what it does, and any other relevant information. So I'm going to click here, create a new file. I'm going to name it readme.md for Markdown. Markdown is basically an easy way to format your text in these sort of files. So I'm going to come down here and type some text. Now Markdown has all these shortcuts like one hashtag for a main header. So I'm just going to put demo here and then some plain text. So I'll put some description and then I'll scroll to the bottom to commit the file. In other words, save this file. I just want to point out really quickly that this create readme.md is placeholder text, but if you don't write anything else here, when I commit this, it will use this text as the default. So let me commit. And you can see here that this is the commit message from when I saved this README file. And now you can see the README file, which because it's named readme.md is the default file that GitHub always shows down here. I can also go into the file here, which is the same thing, except with a few different options here. And in either screen, I have this edit this file option. So I'm going to go ahead and do that. I'm going to simply change this to an exclamation point. Now the default text instead of create readme.md is now update readme.md, which isn't that descriptive, but it's okay for right now. So I'm going to commit, and by committing, I saved my changes here. And if I go to the demo repo, it shows my last commit message here as update readme.md. Now, if I want to see my entire history of changes, in other words, every commit that I've made, I can come here to commits, and each commit has a unique identifier, and I can also see the message or the title that I wrote on these commits. So I can come back to this one and see what was added. This green with the plus signs means these lines were added to this file. And then I'll go back. And in the updated commit, it shows me this red with the minus sign. That means this line was deleted, and then the green with the plus means this line was added. Anything that's white means it stayed the same. So this is a very basic view of seeing changes. Now, what about using this on your local machine? If you are using a Mac or Linux operating system, you should already have Git installed. You can check this by opening your terminal or command line application and typing in git space -- version. If Git is not already installed, I highly recommend checking out this tutorial by Atlassian, which I will link in the description below. It walks you through how to install Git on any operating system. Now, I do want to note for the Windows installation, when you download the Git Windows installer, I recommend you choose the Git Bash option from the install menu. You can, of course, use command prompt and it will set up Git in command prompt for you, but in the past I've had an easier time with Git Bash on Windows. For Mac, it gives you a few different options for install, but I highly recommend you use the Homebrew Package Manager if you can, and it takes you through all of the steps here. But again, you probably already have Git installed if you're using a Mac or Linux, and don't need to worry about this. There's just one more piece of setup before we continue with the rest of the Git tutorial, and that is getting a code editor. Of course, you can write code in whatever you want. Any type of word processing software will do, from Notepad to Microsoft Word, but there are specific ones made for coding, and many of them are really good and free. Visual Studio Code is a free code editor made by Microsoft, is widely used with people learning to code and professionals alike. So you can install it for free from code.visualstudio.com. It's available on every major operating system, Mac, Windows, and Linux. Now I have Visual Studio Code open with no files or folders inside. If you haven't used this before, then all of these icons on the side are how you're going to navigate around your project and use your tools. So I'm going to come to this top one, and this bar comes out where I'm going to see all my files and folders. I'm just going to open a folder real quick. In this test folder, I'm going to go to my Git. Then this is an empty folder that I have. I'm going to click open. And now I have a folder that's open in Visual Studio Code that I can actually add files and folders to. But I'm not going to right now because I'm actually going to pull the repo that we created at the beginning of this tutorial here on GitHub. I'm going to pull that to my local system using Git. So in Visual Studio Code, I have access to a terminal from here that I'm going to use. If I come up to the top, in the View menu, I'm going to come to Terminal and select it. And now it opens this terminal here. By the way, the only reason why this says Git is because my folder is named Git. And because I've opened the folder here, it automatically uses that as the directory for my terminal. So now I want to clone down my repo to my local machine. I want to pull all that code down here so I can work with it locally. I'm going to use a command called git clone. And then in clone or download here, clone with SSH, exactly what we just set up. So I'm going to copy this, go back to my terminal and paste. And I'll hit enter. And now we can see a folder here, which is my repo from GitHub that's pulled down into the directory that I am in. So I'm going to move inside this folder real quick from the command line, which I can just do by cd and then the name of the folder to change directory into the folder. So now I am inside of the folder demo repo, which was the name of the repository we created on GitHub. So when it pulled it down, it gave the folder this name. So my whole repository is inside of that folder. And now it says Git master. Now this might look different on your machine. This part looks different on every machine. I have a specific setup to make it look like this, but either way, you will probably see some kind of indication that you are in a Git repository now. Now, how do you know? This looks like a regular folder and a regular README file. Well, there's actually a hidden folder that you can't see here and that you won't see on most operating systems unless you have selected to show hidden folders, and that is called the .git directory. So there's just a special command in my terminal that I will use to show you that folder. Now the LA command that I used here is actually a Mac shorthand for ls space -LA, which means list everything in the directory, including hidden files and folders. So if you're not on a Mac, I don't think LA will work for you, but you can use ls space -LA to do the same thing. So you can see here's the README file, and then there's something .git. And because it's blue here, that means it's actually a folder. And this hidden Git folder actually stores all of the files that save your commits or your code changes over time. It has all of the changes recorded in the history of this repository, which includes the ones we made on github.com. So now let's make some more locally. I'm going to go into the README file and come here and add a subheader. Not too creative, I'm just going to call it subheader, and then some more text. Now that I have changed this file, I need to save the changes in Git. So I do that through a commit still. So first I'm going to use the git status command. Now the git status command shows me all of the files that were updated or created or deleted, but haven't been saved in a commit yet. So for example, if I come here and I create a new file, I'm going to call this index.html, and I'm just going to put a quick div inside with nothing else. And now let me rerun the git status command. And now you can see I have one file that's been modified and one file that it says is untracked, meaning Git doesn't know about this file yet. So you have to tell Git to track the file before you can save it to Git. To do that, you need to use the git add command and then tell it which files to track. Now most of the time, or a lot of the time, you see people use a period, which means you're telling Git to track all of the files that are listed here in both the untracked and the modified section. So both the changes we made to README and the new file index.html would be staged with Git if we did git add period, because it includes all of the files. You could also optionally tell it just the names of each individual file or folder that you want Git to track. In this case, I'm just going to use the dot. Now I'm going to use git status again. And now you can see that all of the changes have been tracked. That's why they show up differently now. And they are ready to be committed. So I'm going to come here and do git commit -m. Now -m is for message, and you need to have a message in order to commit your files. The message could be one character and meaningless if you want, but there needs to be a message. And ideally that message should have something to do with the what and why behind the commit you're making. So I'm going to add a message here. Added index.html, and this is just the title of the message. If you remember from the web interface, there were two boxes, a title and a description. This first -m and what's inside of the quotes is a message. You can add a second one for the description box. So I can say some description, and I'll click enter. And now it gives me some information, 2 files changed, 5 insertions. But we've still only saved our code locally. The commit isn't live on GitHub yet. We make it live by using another git command called git push, which means I want to push this live to a remote repository where my project is hosted. In order to push them to GitHub under your account, you're going to have to prove to GitHub that you are the owner of your account. So you have to connect your local machine to your GitHub account somehow. The way this is done is by using SSH keys. You need to start by generating a key locally using the SSH keygen command. Then you specify the type of encryption, and then the strength of encryption, And at the end, you need to include your GitHub email address. This is just a test for me because I already have keys set up, so I'm just going to put a fake email address. But make sure that the email address you enter here is the same one you use to log into your GitHub account. Click Enter. Now the default file for the SSH key is inside your user directory in the .ssh directory, and it will be called id_RSA. I'm going to give it a different name here because I already have a key under that name. You can optionally enter a passphrase for your key here or leave it blank, so I'm just going to click Enter to leave it blank. And my key has been generated. Now I am going to search for the key that I just generated, and now I find that there are two. So there's testkey and testkey.pub. So testkey.pub is the key that you're going to upload to your GitHub interface. Pub stands for public. It's called your public key, which means that it's okay for other people to see this key. The key that was generated without the .pub extension is called your private key and is the one that you have to keep secure on your local machine. You don't share this key with anybody. How it works is that the public key you put on GitHub, and then every time you want to connect to GitHub or push your code on GitHub or use your account via your local machine, you use your private key to show GitHub that you are the one that generated this public key. It's a mathematical proof that only this private key could have generated this public key. I'm going to print out this public key. And your key should look something like this. SSH-RSA, it starts with this. It has a bunch of characters in the middle and it ends with your email. Now you need to copy this whole key, which you can do by highlighting it in your terminal or command line, which automatically copies it. You don't need to do Control or Command C, because Control C actually means something completely different in the terminal, not copy. There's also a terminal command that allows you to copy. It's called pbcopy, and then you do the less than symbol and then the path to your file. So it's in our user home directory, and I didn't actually put it in the .ssh directory, but this is the directory you would have your key in. And then it's just testkey.pub. And now it's copied to my clipboard. On GitHub, I'm going to go to Settings, and in the list of all settings, I'm going to go to SSH and GPG keys. And you can see any SSH keys associated with your account. Then you just click on New SSH Key. You can give it whatever title you want. This is just for your reference. And then you paste your key in here. And I'm going to remove the extra enter at the end. And now add SSH key to confirm my password. And now you can see my key was successfully added. The only thing left to do is to make sure that your local Git command line interface knows about the key you just generated. And I'm going to link all of these steps in the description below. You need to start the SSH agent. Then if you're using version 10.12.2 or later, you will need to modify this file, your SSH config, and add this text to it. I'm going to just show you how to get into that file now. Paste the location of the file in your SSH directory, and then anywhere in this file, perhaps at the end, you can paste in that information. I'm not going to do that because I already have my file set up, so I'm going to delete it. After you do that, you'll run this SSH add command from your terminal, and then your key will be set up to work with Git. Again, all of the information that I covered with keys here is going to be linked in the description below, but this is the general way that you will do it with any operating system, although there might be some slight variations. Now there are two more arguments we have to put here. The first one is origin, and the second one is master. Now origin is an option set for us here, and is basically a word that stands for the location of our Git repository. Master is the branch that we want to push to, and we'll get into what that means in a minute. I'm going to click enter, and now I'll refresh this page. And you can see my code changes are all live on GitHub now. You can also see that there are 3 commits, 2 that we made online on github.com and 1 that we made locally and pushed up to github.com. Of course, this was our commit message that we made locally, and this was the description that we wrote after that second -m. We can see all of our file changes that we made locally here as well. So this was to demonstrate how to create a new Git repository using GitHub, but what about if you start a repo locally? So let me exit out of these, and I will create a new folder here called Demo Repo 2. Drag it outside. So now it's in a completely separate folder from the other Git repository that we have. But this one's not a Git repository yet and nothing's in there. So I'm going to move into that folder in the terminal, Demo 2. So now I'm in Demo 2. You can see it's not a Git repository. Even if I look for that hidden Git folder, it's not there. So let me first add a file in here. And I'm again going to add a README file, .md, and I'm going to add a header, Demo 2, and some text. Now, if I want to turn this into a Git repository, I can use the command line and say git init. And it says initialized Git repository in yada yada this folder. And now you can see I have the Git keyword there. And if I do git status, I can see there's this untracked README file. I will go ahead and add that file, either with the period or the name of the file. Git status again. Okay, so the file is ready to be committed. And now I will do git commit -m created README. And now I'll put description here and enter. Now what if I want to push this live? Let's try git push origin master. And now you can see it's giving me this error, fatal. Origin does not appear to be a Git repository. Because we didn't clone this down from a Git repository, we didn't already create this repo on GitHub, we created it locally. So Git is saying I have no idea where to push this to because it's not connected to anything. So we have to create that connection. And first, the easiest way to do this is by creating an empty Git repository up on GitHub. So I'm going to come here, create new repository. I'm going to call this Demo Repo 2. Don't need a description. Going to leave all this here. Now I have another empty repository. So to start pushing here, I'm going to copy this and say git remote. Now remote means somewhere else but not on this computer. We're going to use this to add a reference to the remote repository on GitHub. And then I'm going to say add origin and paste that link that I copied. And I can check that by saying git remote -v, and it shows any remote repositories that I've connected to this repo. Now that these are set up, I can now use git push origin master just as I did before. Now there's a shortcut here because if I don't want to type out this whole thing every time, in the future I can just use git push, but I have to set something called an upstream, meaning this is where I want to push it to by default. So I'm going to do -u for set upstream and then enter. And in the future, I can just use git push without typing out origin master. It says to GitHub. Looks like everything was pushed just fine. I will refresh this page and I can see the README that I just added. So that's how you initialize a repository locally and push it to a remote location like GitHub. So let's review the workflows that we've gone over so far and compare the flow of adding code in the GitHub interface versus writing it locally. So when we first started working in the GitHub interface, we wrote some code in the README and then we committed our changes. We saved them to Git. Now notice there wasn't an add step here. We never did a git add to stage changes. Well, that's because GitHub handles that for us. So really by committing in GitHub, we are adding and committing at the same time. And then that was it, really. Because it was our repository, we had full access to change whatever we wanted. We could just update the code just by committing it in the GitHub interface. Of course, we didn't have to push the code because it was already live on GitHub. There's no other remote repository because it's already in the remote repository. Now, if we didn't own the repository or we didn't have access rights, or we needed other people to review our code before we merged it in with all the rest of the code, then we would also have to take the extra step of making a pull request, which is something we're going to cover later in this video. So let's compare this workflow if we're just writing code on GitHub versus doing it locally and then pushing it up to GitHub. So locally in our text editor, we wrote the code, and then we had to do git add to let Git know about the changes. And then we saved them to Git using the git commit command, and then we pushed them to the remote repository on GitHub using the git push command. And that updated GitHub's code, or the code in the GitHub repository, with our changes that were made locally. And then, just like before, if we didn't have access rights or we needed a code review before we merged changes in, we'll need to make a pull request. So these two methods cover the most basic ways to use Git by using the GitHub web interface and then doing it locally. If you have any questions about this, then please leave them in the comments below. Otherwise, let's move on to Git branching.